Hello. All right. All right. We're going to get started. So thank everyone so much for coming. I know that there's some folks standing. If you can brave the middle, there's plenty of seats in the middle of both sides. So feel free to jam in. So once again, thank you so much for coming. Coming to chat with me about Kubernetes for app developers. I'm really excited to be here today and talk from this kind of perspective. I think that we might not have had so much of the app developer perspective in sort of recent years in the Kubernetes landscape. So a little bit about me in terms of kind of like the two faces of Aaron. I made a career change this year, right about the middle of the year. Before around April 2018, I was an engineering manager in the Azure Containers group. So we were responsible for things like AKS, Azure Container Instances, and I focused a lot of my time on connecting clouds more integrated with clusters. So I was a chair in the SIG Service Catalog group, which there's a couple of sessions around that at this conference, so I highly encourage you to go check those out. And we did a lot of work with brokers, with service brokers, and trying to get cloud services. Can you still, yeah. And trying to get cloud services more deeply integrated with clusters. So since then, since I made this change, I went over and became a cloud developer advocate in the Azure group. And on that group, I focus a lot more on app developers. I actually am an app developer now. So I look at things now in the Kubernetes world from the landscape, from the perspective, I should say, of what does it mean to write code and then have to go and get that code running in your cluster, in production, live on the internet. So I actually kind of have both perspectives now. So I look at it from how do I write code and what are the problems I encounter and the challenges getting that code into Kubernetes. And then from the operational side, I get the perspective of, okay, well, how can we solve that problem? So when I was researching this talk, I came across this tweet from Matt Farina. And so I DM'd Matt. I talked to him. I said, hey, is it cool if I use this in my talk? He was gracious enough to say yes. But B, I also asked him, well, what did you really mean by this tweet? What did you mean specifically by UX? And he told me that he was thinking about app personas, about personas of the folks who are using Kubernetes. And specifically, he was thinking about the difference between an app developer and an operations person, a DevOps person, let's say. And that really got me thinking. I was thinking, okay, well, what does that really mean? What does it mean to be an app developer on Kubernetes? And by the way, when he said that, it was huge validation for me that this talk would be something, because he was thinking about the same thing that I was thinking about. So I got to thinking, what does it mean to be an app developer? I drew on some other folks' experiences. I drew on my experience now, and I was a real-life app developer a long time ago, so I drew on that experience. So like everything in software, I tried to boil it down into 3 bullet points. This is what I believe an app developer is. This is the persona that I'd like to submit for this talk. So we always talk about business logic. Business logic. And business logic is the stuff that actually makes the app the app. So it's everything except for the bash scripts you need to write and the CI, YAML for your CI system, and the underlying sort of plumbing code. And really in modern days, it's sort of like your business logic, the stuff that makes your app unique, plus you're probably writing some glue code to take cloud services and combine them together in the right way. And the second point here is that you're focused on the product. Anything else that you do besides the product is what we call undifferentiated. And I've heard that term quite a bit at this conference, but also it's sort of just so undifferentiated really is just stuff that you do that doesn't move the needle. So it's stuff that you do that doesn't really help your app and it doesn't help your customer. And if you do work with a product manager or you do have a Trello board of some kind, it's the kind of things that aren't going to move those cards in the Trello board over to the done column. Extra work. So for a developer, that's kind of painful to have to go and do that extra work because you're not making progress at your job. And so I spend a ton of my time trying to convince folks to come try out Kubernetes. And everyone wants to try it. That's the good news for all of us. There's 8,000 of us here today for this whole week, and we all love Kubernetes, and we all want to use Kubernetes. But the great news is, outside of this conference hall, there are 10 or 100 times as many people who really want to get involved with Kubernetes. They want to get their apps running in the cloud on Kubernetes, and that's sort of their gateway into taking advantage of all this amazing cloud-native technology that you can layer on top of Kubernetes. So that's the good news. The bad news is when people try and get started, they hit a wall. They find that they have to learn so much stuff, they have to do so much troubleshooting to even get their app up and running that they get frustrated. And they're not frustrated with Kubernetes. They're frustrated with themselves. The fact that they can't get their app running where they think they should. So let's dig into that a little bit more. So there are some fundamental problems here. Here's some laughs for the first one, but that's a real thing. Okay? If you submit a bunch of YAML, let's say you've got 100 lines of YAML, Kubernetes manifest, and you submit them, your feedback loop is pretty difficult. You'll have your YAML, you'll submit it, you'll go and do a kubectl get pod or describe pod or something like that. You'll look through a bunch of YAML that's spit out on the command line. You'll figure out what happened. Maybe you got your image tag wrong, or maybe you had a typo or a tab error, or something like that. And you'll resubmit. That's your dev test cycle. That can get frustrating. And so I say, why won't the reconciler love me? Because what you do with kubectl create is essentially fire and forget. It's an asynchronous operation. And so it's on you to follow up after that async operation. And it's on you to go figure out, okay, now that the reconciler took over, it tried to make the world that I want, what happened? And that's frustrating if you have to do that over and over. And as a beginner, you do have to do that over and over and over again. You might be doing it for hours before you can see something running in a pod successfully on Kubernetes. So that's the first thing. The second thing is Kubernetes doesn't really clearly define what an app is. And that's an issue if you're trying to build an app on Kubernetes. Because if they don't define what an app is, they're not paying attention to the app developer persona. When I say they, I mean all of us. If we don't all agree on what an app is, and there's some work going on to make that a reality, to agree on what an app is. But at the moment, if we don't agree what it is, then we can't provide the best tools to build and maintain apps. And then this last point about conceptual overload and context switching, this is the part that frustrates ongoing. As you're maintaining your app, as you're extending features, as you're growing your app, you get super popular as an app, as you scale up, the conceptual overload gets stifling. So a great example is if you have an app that adds a couple more domains, maybe a domain for your HTML front end and a domain for your API, you're going to have to learn about ingress. And learning about ingress itself is not a huge deal because it's YAML. You write some ingress resources and you submit them. But then learning about ingress controllers is difficult because there's so much choice, you get paralyzed by it. And then you layer on a concept sort of on top of ingress controllers. That's things like how do I provision SSL certificates? And that's things like what cloud load balancers should I use? And that's things like can I use an ingress controller to manage my cloud load balancers? And that's also just the mere fact that you have to figure out that your ingress controller needs a service in front of it to expose that to the internet. So there's a lot of layered pieces there that don't necessarily fit together so well unless you read a couple of different blog posts and spend maybe a couple of days trying to get this stuff set in your mind in sort of the right layout. And so let's dig in a little bit to that conceptual overload. So this is the approximate list of things that you're going to have to learn before you can deploy your web app from the first time. So you go from just code to Kubernetes running in production. This is just about what you have to learn. And it's not really that you just have to learn like the YAML for it. It's that you have to learn the concept. So quick poll, a show of hands. Does anyone think they can write a Helm chart right now without going to Google that includes every single one of these resources? Raise your hand. 1, 2, 3. Getting cocky. 4, 5, 6, I think. Okay. So that's 6 out of a room of maybe approximately 150, 200 people. My estimating skills are right. Was that 200? Oh, it's 400. Ooh, thanks for coming. Yeah. All right. Ooh, I'm feeling, yeah. Okay, so that's what, 6 out of 400. So that's telling. And for those who raise their hand, I salute you. You have memorized a lot. You have conceptualized a lot up there in those heads of yours. But it's very telling that everyone else can't. Because if this is what you need to deploy a web app and you can't remember it, that means you're going to docs. That means every time you want to upgrade something, you want to add some functionality to your web app, you're probably going to have to go to docs. And eventually, you're probably going to have to go look at a YAML reference. And also, RBAC is tough. I still don't understand RBAC. So let's talk about YAML. There's a lot of YAML bashing in the Kubernetes community. A lot of people say, hey, we should get rid of YAML. It's going to make the world better, a better place if we get rid of YAML. A lot of people believe that. I would love to not have to write YAML. No tabs, that'd be great. Not setting up my VS Code the right way and installing the right YAML plugin. Great. That sounds great. But at the end of the day, if we do replace YAML with something else, the problem's not going to go away. You're still going to have to understand all this stuff. Maybe you'll be writing these resources in TOML or HCL or HOCON. Let's use XML. Let's just move to XML. So you're going to have to end up writing these resources and understanding these resources one way or the other. Why is that? Well, that's because Kubernetes is the operating system for your data center, or your data centers, or your regions, or whatever you're running on. And an operating system exposes primitives. So if we're going to compare Kubernetes, the operating system, to Linux, either way you get primitives. You get syscalls and network access and raw files and stuff like that. Well, the equivalent in Kubernetes is this. And so without something to abstract over these, let's call it a framework, whenever you need to deploy your web app, you have to build your own framework to glue this stuff together and so that you can conceptualize it in a human consumable way instead of a Kubernetes consumable way. And I think it's said many times that abstraction is one of the solutions to every problem in computer science. This is no different. Okay, so let's pivot a little bit. And let's talk about abstractions. Okay, so we don't necessarily need to abstract over every single one of those resources in that list. That would be a lot of work. And we also don't really know exactly what that abstraction should look like at the end of the day. So let's inform that abstraction with some case studies. And from those case studies, we can pull out some common patterns, and then we can target those patterns to abstract over. Okay, so the first one is the lowest hanging fruit. I talked to quite a few folks who do use Heroku, or they use Zeit, or name your favorite pass. And the one amazing thing about all these passes is it's literally one command to get running on the internet. Public IP, a lot of them even provide you with a subdomain. You run git push, in Heroku's case, and you've got your app running. It takes care of everything else. You can get fancier if you want, but basically that's how you start out. And in this use case, really, this is probably a hobbyist or someone who's building a startup or something like that. And if we talk about undifferentiated code, these are the people who are the most allergic to undifferentiated code. These are the people who are most sensitive to the fact that when they're writing that undifferentiated code, the glue code and the infrastructure code, that they're really losing time. If you can imagine writing an app to scratch your own itch, on a Thursday night. Well, anytime you have to learn some YAML, that's cutting into those hours. And so that's why people reach for Heroku and other PaaSes, right? So I'm not suggesting here that we need to make a PaaS on top of Kubernetes, but we need to provide a solution that's PaaS-like to someone who wants to get into Kubernetes on sort of day one of their app. Okay, so now going a little bit more in depth, this is a case study when someone is running inside of Kubernetes already. So I've talked to customers, I've talked to friends, I've talked to acquaintances, people have DM'd me on Twitter, and the common question, once you're running in on Kubernetes, is, my app needs state. What do I do? Almost certainly, people who are running in the cloud are going to want to hook their Kubernetes app up to RDS or Azure MySQL or whatever cloud-managed database is out there that they want to use. But there's a problem here. There's friction between your cloud portal and your Kubernetes world. So how are you going to provision the database? And let's update Firefox a little later. So how are you going to provision your database in your cloud portal or your cloud CLI? And how are you going to get those credentials and that host name and that username down into your Kubernetes world? Are you going to copy and paste it? I love copying and pasting into my 1Password and having that be my key vault. Are we going to do that? That's reasonably secure. But once it's in your secure or not secure place, whether you write it on a Post-it note and transcribe or you put it in 1Password, how are you going to get that into your Kubernetes, into your Helm chart, or somehow into that Kubernetes secret? Are you going to copy and paste every time? Are you going to have that one person who has the 1Password open on their machine? Are you going to paste it into a private GitHub repository? Is it somehow going to be floating around there in your CI system? Well, there are kind of shades of security in there. It's on a spectrum. But regardless of what you do, your password is going to end up kind of splattered around your universe. It's going to probably be copied in 1, 2, maybe 3 places. And that can be an issue. Let's say you want to go rotate your credentials. Your password gets compromised. Who's going to remember where that password is? All the different places where the password is. That's a tough problem to solve. And then finally, injecting the password into your app is not the biggest deal because we have secrets and we can mount secrets into environment variables. Folks in the app development world, I think probably everyone at this point knows about 12-factor apps, or most people knows about 12-factor apps. And if you do, but you can't use them, or you don't, but you use a framework, your framework or your code will have a way to take credentials in, whether it's by a config file, whether it's some fancy environment variable that has everything. It kind of doesn't matter because everyone knows how to get credentials in. But the question is, what's the best way to get credentials into your pod spec? And that's a fundamental distinction. And there are a variety of different ways to do it. You can do a volume mount. You can use Vault. You can use your cloud-specific key vault, KMS or Azure Key Vault or whatever it may be. There's a ton of different ways. But we don't really have a best practice. Every single team has their own best practice on how to inject that stuff into your app. And while we're talking about databases, let's talk about database migrations. So show of hands, who has done a database migration in their life? Over 3/4. Okay. Now, put your hand up if you've ever crashed your production app doing a database migration. Okay. Wow, it's a lot less hands than I thought. Okay. Raise your hand if you appreciate how difficult conceptually it is to do a database migration. Yeah. Okay, that's what I thought. Yeah. So, and that's before Kubernetes, right? If you're doing your database migration just running on a VM or your laptop, you got to keep a lot of stuff in your mind. Right? Your code, your old code has to be tolerant of the new database schema, and then you've got to actually run the migration, and you might test the migration out, and then you got to deploy the new code and look for errors. And then you got to think about rollbacks, and I still don't even know what the solution to rolling back database migrations are, and then my head explodes. Okay. So now layer Kubernetes on top of that. So I talked to actually more than 3 groups at Helm Summit earlier this year in February. And I asked this question, well, how do you do your database migrations when you're running 1,000 replicas of your app in Kubernetes in Cloud X? I got 3 answers. 3 people said, nope, this is the right way. This is the only way. So some people just with each replica runs the database migration and one wins, and that's totally valid. A lot of people run it in a init container. I followed up and I said, well, what does the init container do exactly? And then how does it know to end? And what happens when there's 1,000 init containers running? I don't know. And then this one is my favorite personally, is some people run a job. And when the job completes successfully, then they know they're ready to deploy. And I followed up with, well, what tools do you use to figure out when the job succeeds, when it's done? Do you watch the event stream? Do you just poll with kubectl? I don't know. So all of these things work, clearly. But there's no sort of right way. And even if there was a right way, or all of these things are fine and you can choose, there's really no tools that encode how to actually execute these actions. It ends up just kind of reducing to a bunch of bash scripts, or endeavoring folks will write a Go tool to do it. And then the last case study is Athens. Now this is a project that I'm a maintainer on. It's a global proxy for the new Go dependency management system. And it's deployed at a bunch of AKS clusters in various regions around the world. Okay, so it's not the craziest of Helm charts. It's about 300 lines of YAML when I measured at the end of November. But I think that we've fat-fingered just about every one of those lines. Helm lint has probably caught 75 to 80% of those fat fingers, and that's great. But there are some fat fingers that Helm lint didn't and shouldn't have to catch because they're app-specific. So that's things like we forgot that the Docker image tags should start with a V. It's V O.1.0 and not just O.1.0. Oops, forgot the V. Or maybe we fat-fingered to a C, which is right to the left of the V. Right? Helm lint shouldn't catch that, but someone needs to catch that, and we can't rely on ourselves to do it. And that kind of brings me to what is ourselves? In the Athens group, there's a huge variety of folks around the world with varying different levels of understanding and expertise with Helm and Kubernetes. And we don't quite have the tooling to support all of them. The best thing we can do is Helm lint and PR reviews. And then the last piece is, well, we haven't really gotten around to setting up CI/CD. So luckily, this thing is an experimental server right now. We haven't really gotten around to setting up CI/CD yet. It takes a little while to do. So that's a bummer. But also, once we do set up CI/CD, we're eventually going to end up with a for loop in Bash, most likely, that just does Helm installs on each region. We checked out Federation a little bit, and Federation is kind of coming along, and I think we could use it eventually. But meanwhile, there's not really a best practice for app developers on how to deploy to different regions. I've read a ton of stuff about it. I know what some folks are doing successfully. I know what some folks are saying is the best practice. And that's cool, but I have to figure out at this point how I'm going to implement that best practice. There's nothing that really encodes it for me, or a tool that helps me do it. And so from these case studies and more, patterns start to kind of fall out. So the top there is sort of for the hobbyists, right? One command should probably be able to get you started with a super bare bones, simple deployment, probably with no database, but something that shows that your effort paid off to make the jump over to Kubernetes. And then as you go, you should be able to add things like that database, or maybe add things like that new host name for your API. And then we get into configs, right? We know YAML is tough. If we're going to keep writing YAML, we should keep writing tools that help us maintain it and error check it and so forth. And then those last two are sort of tied for first in my mind. So when I think of connecting databases, I think of state. And state is crucial for any app. It's the most important piece of any app. I think we all probably could agree on that. And if you don't agree, you can come yell at me afterwards. That's cool, too. But once we're talking about state, we're talking about databases. And once we're talking about databases, we're talking about passwords and ACLs. And once we're talking about passwords, we're talking about security. We're talking about getting those passwords into a secure place that only your app can access them. And once your app does access them, that you can audit that access. And most importantly, potentially most importantly at least, is you can rotate those passwords. That's crucial. That piece about rotating passwords is like the day 60 concern that really needs to be thought of on day 1. And hopefully, that'll be thought of by someone else besides the app developer. And that's what I mean by encode things. Reading blog posts is amazing, and I'm so glad and grateful for the community for writing down absolutely everything that they do in production. But at the end of the day, if I read blog posts, I need to figure out how to implement that stuff. And encoding that stuff is the most important piece of the blog post. If a blog post says this is what you should do, I'm almost certainly not going to do it unless there's a tool that makes it easy for me to do it. And that's because that tool to an app developer is undifferentiated code. And so from those patterns that fell out, I'm introducing this fictional tool called Tango. And actually, Tango has a repo with a 3-line README and skeleton CLI in it, but it doesn't do anything right now. But I'm introducing it as sort of a placeholder for how should we encode these concepts for an app developer. And so let's do some sort of README-driven development in this talk. Let's go slide by slide and talk about the different commands that Tango should have and which one of those patterns it can address. Okay, so we've got our first one. This is the entry point for any app developer. They run install. And install is a one-time execution per cluster. You don't have to run it every time you build an app. You don't even have to run it on your machine. You can get a cluster, run it in the cloud somewhere, and you're done. The cluster is ready to Tango. I just made that up right now. I'm pretty proud of it. And so Tango install will set up your environment to do your Docker builds. Maybe you'll do it on a hosted, in the cloud hosted somewhere. Maybe you'll just have your local daemon. Maybe it'll be on Minikube or use Knative or whatever. It can be all abstracted away. And then it can also set up a bunch of in-cluster things that enable these best practices that Tango will encode. So that's things like Tiller for Helm charts, Jaeger for tracing, the best ingress controller, maybe Prometheus for metrics, maybe wiring up metrics to some hosted metrics system, maybe wiring up Splunk logs with a sidecar. The possibilities are endless. And this is a really important abstraction point because this is the place that you set someone's cluster up to be the cluster for them to do the work on. There's nothing else they need to do besides this, and then they're ready to go. The cluster is ready and has everything they need to Tango, like I keep saying, because now I'm really proud of that. Okay, so the next abstraction point is init. So I work for Microsoft, and I'm contractually obligated to put Clippy somewhere on each slide. Just kidding. But init is basically the wizard. For each app, you run init once, and it figures out almost everything that you need to make that app follow the best practices of Kubernetes. It might ask you for a few things. Maybe it'll ask you for your app name, or maybe it'll ask you what kind of Docker file you want. But overall, it's going to figure most things out for you. And it might write a bunch of files into your Git tree. And it might tell you can check them in. And that's all good, but you shouldn't have to look at what those files have on day 1. Maybe you'll learn here and there, and you'll go to day 6, and then you'll start messing with those files. And Tango should respect that. But on day 1, Tango init writes a bunch of stuff in your repo, maybe writes a bunch of stuff into Kubernetes, and that's it. Okay, and then next up is deploy. This one's probably fairly obvious. But what's important is this is another very crucial abstraction point. Because behind deploy can be a very complex workflow of things. Of course, it's going to start with building your Docker image. But in there, you can follow some best practices. Right? It can encode things like immutable Docker image tags or canary builds, things like that. And then that second step under setup, well, that can encode tons of stuff. that can encode new monitoring setups, new tracing setups, so on and so forth. And we're going to skip over duplicate. Duplicate's a little bit more complicated, but if we go into the repo, which we'll do in a second, we can kind of see how that works. And then delete basically does the opposite of init. And then service is the one that's near and dear to my heart. This is the one that goes from provision the database all the way to get the credentials into your app. So those are sort of the high-level components of Tango, let's say. But the good news is that we're not trying to invent anything new here. We're trying to curate a bunch of services together, put them together in the right way that follows best practices. So I call it an extraction and not an invention because that's what we're doing here. We shouldn't be writing a lot of new code. We should be writing a lot of glue code. So I'm going to mention two of the tools that I believe Tango should probably encapsulate. One is Draft. I don't have time for a demo right now for Draft, but I'd love to show you one after. Draft is the dev workflow that I think probably Tango should follow. It's two commands. One command to set up your repo, basically Tango init, and then another command to deploy the app to your development environment. So you can literally do remote debugging from your local host into your cluster. And that cluster is Kubernetes, so it can be running anywhere. Cloud, local, in a VM, doesn't really matter. And then there's Keel. So Keel is an operator that runs in your cluster, and it watches for new Docker pushes. It'll listen to webhooks for all the major Docker repositories, or it'll pull. And either way, it lets you follow GitOps. So if I do a git push, my CI/CD system can take over. It can do the tests. It can run the Docker image build. It can do the Docker push. And then once the Docker push happens, CI/CD is done, and Keel takes over. And Keel pulls the Docker image down. It does the deploy inside the cluster. And that's the thing that can wire up all the fancy canaries and monitoring and so forth. And I really like their catch line down there at the bottom. No CLI API required. So when I was first looking for a solution like this, I chose Keel. I started researching Keel because of that. So I'm going to have to skip over the demo for today. But I'd love to show you afterwards if you want to come check it out. But there's more. There's tons more. There's tons more best practices and tools and concepts that this thing can and should encode. Everything from functions as a service down to remote debugging and security and distributed tracing. And all of this stuff can be encapsulated inside of this tool. And if you go to cncf.io or go to GitHub and look for all the Kubernetes-y things, there is a tool, one or more tools, that will let you do every one of these things. And so I'll leave you with this. When you're thinking about app developers on Kubernetes, really think about these two personas, the ops persona and the app developer persona. And when you think about that difference, think about the divide. What is the ops persona enabling for app developers that reduces the friction for writing features as app developers? And if there still is that friction, think about how you can compose different tools from Kubernetes together into something like Tango that eliminates or reduces that friction, that allows that app developer to stop writing undifferentiated code. So with that, I really want to thank you again for coming out. And I'd be happy to take questions out in the hall. And you can also stop by the Microsoft booth and get swag. And you can talk to me and a bunch of other folks as well. So thanks a lot, everybody.